We're back in session, and we're going to start with, this is our second class of the third week. I'm just logging things here. And what happened here? There we go. Going to have to get this connected to my computer. I guess we are recording. By the way, I do have some questions about recording this class, or the video recordings of this class. I think we are being recorded, and we're being actually, our videos are saved at this place called Penapto or Penopto, one or the other. It's just a hard word to pronounce. And the way that I know that, let me just go ahead and do that. I think there are two places where this actually could be recorded. Some of the old ones seem to be in one place, and then the new recordings seem to be at a different place. Let me just see if I can go to my site. And what is that? All right. Let me just go to the place. I want to share my screen in just a little bit. Let me first of all get to this Elms place, and I want to share this information because I think some of you are not able to find that thing, that particular place. And I'll see if I could actually help you locate that place. Now I need to get my phone because I have to log into this site. Just give me 1 second. Okay. So here we have this place. Again, you're not able to see it yet because I haven't shared my screen. I was thinking about sharing it on iPad, on my iPad screen, but now I changed my mind a little bit because I want to share this with you. So let me see. Let's just say log in here. Okay. We do that. There we go. I got this dual business here. Okay. Now let me go to that very place where it says Panopto. Okay, where's that 21? ENEE350. All right, let me just share my screen with you, and you will be able to see what I'm referring to here. So here I am, okay? And you should have a copy of all these, most all of these things, and you should have this thing called Panopto recordings. You know, check to see if you have that, first of all. If you don't have this, then you may be out of luck. And I don't know how to fix that problem because university, I think IT office messed this up because we had this nice Zoom recordings before. Now they just switched over to Panopto without our, you know, willingness to do that. Now this I couldn't do it here because my, you know, there is some issue with my this particular browser, but I go to the other place, and I will just simply open this site, and I go to Elms from here, just a different situation. Okay, I think I need to change my settings on my Safari. All right, there we go. So now let's go to the same spot with, and I want to admit Shaman Lane was still trying to figure out how to actually get into this, you know, Zoom room. I think it's a shame that the university has made this so hard for people to come into these classes. I don't know what they're, you know, aiming at, but I'm not pleased with what's happening. So here we go. And again, you will have this Panopto place right there, same as like we saw moments ago. And I'll click on this. So when I click on it, I actually see, you know, just a few things here, not more than that. But there is a place here. You see that little sort of like a ear, like a tab? Just click on that. And there's another one there. I assume it's just loading. That's what I managed to do last time. Not that, not that. I didn't mean that. Wait a minute. I know that I had, there it is, meeting recordings. This is it. This is where you're supposed to click on. Okay. Not that top one, but this one. I think somebody just gave that name because I told them to, because the Panopto was not, I couldn't activate it because they actually locked it out and it was basically grayed out. I couldn't touch it. So if I click on this, okay, you will see all my classes. Like 4 days, what is it? A day ago, 2 days ago, 2 days ago, 2 days ago. You see all of them? They're all in there, right? You see that? Everybody? Jasser?
We don't have
See
the meeting recordings option when we want to choose.
I don't know what these people are doing, you know, like they must be sleeping wherever they work. They created this for me, okay? And I guess I don't know how to make this available to everybody. You know, they just messed it up, completely messed it up. I had maybe like 20 email exchanges with these IT people, my department plus the university, and they still didn't get it right.
I think there's an option where you can move it to the 350 file so that we can be able to see it.
I hope so. I don't know where that option would be.
If you like put your cursor on that video, I think it could be.
Click on it, maybe you mean? Like select.
Yeah.
That's not my class, by the way. This is my situation here.
Yeah.
How
I
do you
think it will be edit, I think.
edit?
Yeah. I'm not sure though. It might be.
You share maybe? God, I mean, you know, look what I'm doing instead of like lecturing you about the stuff that I'm supposed to, and this is not my job. You know what I'm saying? I should not be worried about this stuff. And that's why I get angry at the University of Maryland IT people. What are they doing? Why do I have to do this? What is the point of like me having to organize everything for them or do all the things that they're supposed to do myself? I have no clue. Well, again, I don't want to, you know, like basically go on a tangent and then try these things. It just doesn't make sense. I'm going to write them an email, and you know, I will have them work on this one. I don't know what this is. I mean, I can't change the name of it just to get it into the other place. Yeah, it's just not my cup of tea, okay? I mean, it's just like not something that I, you know, it's not in my pay scale. I don't want to worry about this. I want somebody else to take care of it because it's not my job to see if I could organize these things on University of Maryland's, you know, website. I don't even have, maybe I don't even have the privileges access-wise to make those kinds of changes. So I'll leave this alone. I understand now why you don't get to see it. Anybody is able to see this by any chance? Let me just, you know, like, because you said that you don't see it, but maybe somebody else can see it. Anybody is able to see these things, like these lectures? Anybody could, you know, lay their eyes on them? Like this must be our last class right there. And they're all in there. Okay.
Yeah, I can see it.
You can see them?
The most recent one I have
Yes.
was from 6 days ago.
The most recent one I have is also from 6 days ago. That's the discussions.
Okay.
And then before that is 14 days ago.
But you don't see these, right? Yeah, I guess you, what you,
No, I don't. So I don't see those ones.
what you see is this, I think. You see this.
Yes.
And some not so very intelligent, let me just be gentle about it, not so very intelligent person created this thinking that, you know, you can go in there and you cannot go in there. Now, I don't see these options on here, I can, if I had the capability, maybe I could play with this later. Maybe I could just like change the settings and,
I think the reasoning you're having this is because we are allowed to choose where we want to search. We can choose everything, and then it'll literally show every lecture that's been recorded, all campus wide, which we clearly don't want. So I think you would have to move the lectures that you want into that folder so that we can access that specific folder.
well, it is there. I just showed you that moments ago. If I say everything here, where was that option there? Here. If I go to everything, under this comes up this. I think it does. I thought that I saw it there under
Well,
everything.
everything is going to have all of the lectures. Like I think it's campus wide,
Including mine.
including yours, but it's going to be buried there because there's a lot of lectures coming out daily.
You're
So
saying
all of those
actually-
classes.
Oh, no, actually his are not there because I think they saved it to your private folder.
Oh, okay, it's private. Okay.
Yeah, your folder is private. I think those are the IT things that they did.
Yeah, I don't know whose idea it was to. Yeah, I don't know. I mean, I just have to write them a note saying that, they put it on their meeting recordings. They have to have it in here so that everybody can see it. I have to send them yet another email. You have to prod these people. You have to hold them by their hand and then basically take it to the promised place. They just don't know what to do. And I'm just being angry because, ultimately my students pay for this. A lot of you would have wanted to look at these, videos by now.
Yes.
Right? It's just terrible that these people are so incompetent. I mean,
Just out of curiosity, so if you click on meeting recordings, do you
yeah.
have a way to, is there like a settings option when you hover over a video to sort of, like if you hover over a video and go over share, is there an option to,
Well, I just clicked on it. I didn't click that.
oh,
I
sorry.
just
Yeah,
came
so
here.
no, like do you see where it says share? Is there a way to share it onto
Well,
that
that's
other
what I was
folder?
thinking. Then I have to share these every time that they actually put it on there.
Okay, there might also be another, I mean, this will also have to be asked through them, but there might be a way where you could just have it automatically be that,
Well, I
so that
share
every
it
time
now.
you record it.
I have to invite people. I have to,
Okay, I see, yeah.
I mean, this is just the craziest stuff. It's not something, like this is IT thing. It's not my thing.
Yeah, true.
I should not be doing this stuff. I mean, this is why they get paid. This is their job. I think there might be more than like 50 people working in this place. I don't know what they're doing. And I don't want to, I don't want to sort of like show my disappointment in them publicly, but I really am fed up with these people. I don't know why did they do this in the first place, to take the stuff out of Zoom and put it into this place called Panopto, because it was just nicely recording. Everybody was able to see everything. It was like, it is still like something that Zoom does part of this. Zoom actually does the recording. In fact, as we speak, Zoom is recording this. And then, somehow University of Maryland behind the scene just tries to grab this and put it somewhere. And the person who did this obviously didn't put it in the right place so that you can see it. All that stuff, infrastructure behind that, it's just not something that I should spend my time on. Anyway, it may be another week before actually you get to see these things. I apologize for any inconvenience, but the point is that I could see them, but you can't. And that's because of IT's inability to actually understand what they're doing. Okay, so let's get back to work. Okay, so maybe it'll be a brighter, like afternoon, but with all this stuff out of the way, because every time I look at this IT related stuff, it just makes me concerned, I guess, in a gentle way. All right, I'm going to switch my sharing to my iPad, and I have to get that class open up here. All right, let's see, where am I here? There we go. So, documents, ENEE350, there we are. Okay, so I just want to bring us to the very end of this, and I want to share my screen. we should be good to go. There we are. All right, so we basically stopped here. I guess we stopped right here last time. And yeah. Okay, let me see. I had one thing here, which I think I made some small change. At the end, towards the end of the class, one of the students pointed out to me that I guess IR, or it was, I think IR didn't have the W for it. And so we removed that both from this here. There used to be a W. You can see that, in fact, I left the wire, but that's not supposed to be there. So just for the record, you may want to take it out of there. Also, there was something here, which is down here, which is W, and that sort of disappeared because we checked the circuit, the controller, to realize that there was no W going into. There was, in W, there was no transmission or transfer of something into, I guess, the IR or something that would come from another IR into MAR. That was not there, okay? So as a result, I just simply take those out of there. Now today we're gonna transition to, and we kind of like finished our discussion on, the data path design. What you would normally do, maybe just a little addendum to all of this stuff, is that in order to complete the design of a data path, just a brief note, and an addendum to this earlier material, you will create a table okay. I just want to say this so that you know what you're doing. So what you're going to do, you're going to just create a table, such as this. Okay, so you put all your registers A, B, IR, PC, MAR, MDR. Put all of them there. And it's like a matrix. You do the same on the other side at the top. A, B, IR, PC, MAR, MDR. And then simply note, which of these actually, let's say that this is your source, and this is your destination, and then put a check mark, when in fact something receives from something. For example, we know that we put, when we look at MAR actually receives stuff from here at some point in time in our sort of sequencer, and put a check mark in there. And we also know that it receives something from PC. We put something in there, okay? And I believe we also put, what was it there? That hold on. MDR. You can see that there are these three things that we actually use to excite or put stuff into the MAR. So you know that in this case, what you will do, you will put a check mark here too. So in other words, this particular register receives things from IR, PC, and MDR. Okay. Now for example, A receives something from itself and also receives something from B. Okay. Now B doesn't receive anything explicitly, even though load commands can actually update them. And IR will definitely get something from MDR. So we'll put a check mark in there. Okay, this is IR section here. So fill out this table with check marks. Okay, so fill it out, fill this table. Okay, fill out this table to describe the dependencies. Okay, dependencies meaning the dependencies, but I'm just out of my margin here, as Fermat would say. Okay, dependencies, maybe just write it here, between registers. And then, you would know with this table, by way of this table, exactly how you should create this sort of a circuit. Okay, this sort of a circuit, how you should create it, because what happened? This is frozen somehow. There it is. I had to touch it, I guess. So you know how to make a transition situation, like the data transfers that happen here, or transfers to the MAR register. So this is sort of like something that I left out last class, which I should probably mention here for everybody to pay attention to. All right, so now we're going to go to lecture number 6. And we're going to shift gears here. And we're going to talk about, how to program computers at the machine level. You all have learned how to do things, at, I guess, high level programming languages with those kinds of tools. You know how to write maybe C, Java, Python, and so on, all these other programs that you know how to write, or MATLAB, Mathematica, etc. But all these things are translated into, let me show you this diagram. I think it'll be helpful if I did do that, so that you understand why we have to go through these things, because this is the kind of class where you will learn this. So I will switch my sharing to my desktop. And I'll show you this diagram for you to understand why we're doing all these things. Okay, so you have to probably relate to this somehow. Now here is the representation that I'm actually alluding to. If I can bring it up here, or just maybe make it a little bit bigger this way. So look at this diagram carefully. And what we're going to do today is something that comes out of this diagram. As a programmer, let's say you are in the computer science program and they teach you how to program things, and you learn another one of these languages, and that's your language right there, whatever it is. I don't want to give it a name. What happens that whatever machine that program is compiled upon, and that's one such thing here, you get what's called an assembly level program, which is a program which does the same thing that the program that you've written, except it's a little closer to the machine. It's like below the level in which you write some nice English looking expressions, like for this, do that, and so on. That thing then can be executed, if you like, so that you can see the effect of what you would have seen if, in fact, you just ran your compiler and you looked at some output, whether this was to create an image or to, buy 100 shares of Apple or some other company on a Wall Street site, a browser, whatever that you're doing would have all happened in the same way that you would have seen them happen here if you just, held a light onto this thing, right? If you could see it. So that translation happens. And now you see all the things, maybe not in maybe the same way, but you can see some bits flowing around. Now you take that same program, which is what we call an assembly level program, and you actually subject it to an assembler that takes that program, which in fact came from the one that you wrote at the highest most level. And then you take it and subject to this other program called the assembler, which then creates this thing called an object program. By this time, this becomes a machine program or a binary or a hexadecimal program. Okay. All right. So that program is the kind of program that we're going to write today. We're going to skip these levels. We're not going to look at any of these, but we're going to go straight into this machine program because we created our VESP at the machine layer. And then I could execute it, of course. If I had this system, I think we're going to use the system also, but later on. And, I'm going to explain all the rest of this stuff here, that there are some more things that we have to learn in this regard. But right now, what I'm just trying to tell you is what we're doing, we are basically looking at this so-called object program version of a program running inside a computer. We're fairly down in terms of the layers that, if you peel these, that's why this is called code peel. Okay, like peeling something, like a peeling onion. It's not, it's sort of like, sounds like appealing to you, but it is really the word peel from which the name of this thing comes from. Our goal is to kind of create these layers all the way down to transistors. So you can actually see all the translations that happen between the very high level. And we're going to add an app layer here too. There's another layer up top here, which we haven't shown here, because this is enough for right now. But anyway, that object program is what we're going to focus. And VESP is an ideal outlet, ideal sort of like a simple enough program that I've shared with you last time, which gives us the ability to actually see what machines do at the object level, which is to say machine layer. Okay. We will just be doing that in this technology also, but VESP is simple enough and something that we can put our hands on, and it'll be really helpful if you just, like maybe left all this overhead and then focus on machine programming here. Okay. Now, let me go back and then share my iPhone and iPad again. And then we go to work. All right. So this is our lecture number 6. Okay. And we can give it a title, Machine Programming. Okay. So what we want to do is to use, okay, we want to write a program to, I guess, to compute the following high-level program. And I'm just going to write that now. Okay, this is one of several examples that I think we're going to do. You'll do some and I'll do some. So here's for maybe I1, I less than or equal to 10. Let's just give it a number. And I plus plus. And I want to do this sum is equal to sum plus sum array AI. Okay, so you could write this in C, and then, if you define your sum as an int or something, and then define your array, with a pointer or some other way, you can actually execute this under a main program, and then and then you can print this, and then you'll actually see what the sum is like. Okay, so you can do a printf, or you can do a cout, and then you'll be able to see this thing. So that's what now, and our focus is not so much on how to do this in C or in some other compiled environment, but we want to do this in machine code. How do we do this in machine code? So what this will teach us maybe is twofold. One, we will understand, how we take something like this and translate it into something at the machine layer. And two, it'll also show us how the resources have to be gathered and organized in the machine layer. And there must be an automated process for this. Otherwise, we don't want to do this by hand every single time. We want to do a machine program for this. That's exactly what compilers do. Compilers take things like this and they turn them into machine programs. Even when you write, for example, Java code, Java, there is an engine that actually runs underneath Java, virtual Java, JVM, which then, processes what we call bytecode. Bytecode is sort of like something like a machine code, but it is in Java's, language, layout, if you like, or the structure. And those things have to be ultimately turned into whatever machine that the thing executes on. In other words, if you think about the same description that I gave you earlier, here's your Java compiler. Here is the JVM architecture, which sits underneath Java compiler right there. And from there, you branch out to all these machines. Thankfully, and, I guess Oracle should thank all these companies consolidating into something, just a few architectures are out there where, got the MIPS, the Intel, AMD is pretty much like Intel, and, a couple of other architectures like ARM, Spark. They're very similar in some ways. Some ways they're different. So this JVM has to ultimately communicate with each of these physical chips that with their own languages and turn those bytecode programs into actual machine programs so that they can run on the physical platform. So that's what happens again, from a Java program to a JVM. That was the whole idea. So Java was created with the idea that, okay, well, we don't want to write a compiler for everything. We want to hide that, compiling process from the compiler developers, let's say. We just want to create this JVM underneath, and then we do all the translations down here so people can write a program that will target Intel, MIPS, Spark, ARMS, whatever machine that they want to target. We'll just give them the JVM sort of platform into which they can grow their, high-level applications, and then just create these nice apps that they want to create. Other languages have actually taken a similar tact, and so this has become a sort of a, I would say, a more common place right now. But the real challenge in that translation process, if I can talk to that, is to create a silicon compiler, which is to say, don't do any of these things, in fact, in the soft layers of a computer, but in the hard layers, and have a chip which knows how to compile whatever is fed to it. Okay. And so you don't have to write these, like these programs and call them compilers, just like as we'll learn about these also like micro programs that are actually stored in the ROM storage spaces of computers in the very low microprogram layers, where you can actually change the architecture of the machine, much the same way you can actually have these compilers, depending upon how the space becomes available. And we're going in that direction, solid state, drive, memories, and all these other things are coming along. And ultimately, people will actually put these compilers down into the chip. And that silicon compiler idea will actually happen, which was introduced more than 25, 30 years ago when Java sort of like was surfacing. around 1986 or so. Maybe it's more than actually almost 40 years, close to. All right, so let's just get to it. How do you do this program? How do you convert this to a VEST program? That's our goal here today. I just want to say those things because like you want to get the big picture. What are we trying to do here? I hope that this helped. Okay. So we said we want to basically write a machine program to do this. So in order to do this, we really have to go back to our, structure, what we have. All right. We have instructions that we have to use. So we must do all this stuff, right? We must do all of these. We must do this. Do this translation. From a C program into a VEST program by using the instructions of VESP. We don't have any other capability. VESP has only 8 instructions, and we want to do this in 1.0, by the way. Okay, we want to do all this stuff with just 8 instructions that were given and no more. Okay, so how do we do that? How do we do that? One of the first things that, like compilers will do, and we will hand compile this program now, is to identify all of the critical variables. Like here, we got these variables. Like there's a variable called sum. There's a variable called I. And there's an array A, which we have to index somehow. So we have to create now, variables that would represent these things for us. That means we have to go, before even thinking about, we think about, what instructions to use. What we have to do is to lay it out inside our so-called memory, VESP's memory. Okay, so our first step is lay out the variables into the memory space of VESP 1.0. Let's just go ahead and do that now. Okay, so the first step is basically do this. Let's just go ahead and do it. So now let's remember that we had this. Okay. Anyway, let's just, I don't know, I just didn't get that right. Okay. So we know that this location is sort of like reserved. That's our location 0x. Let me just draw a couple of these while I'm at it. Okay. So now let's write, this is 0x, 0, 0, 0. And this is our A. That's a reserve, we can't use it. This is 0x, 0, 0, 1. This is B. These are off limits. We cannot touch them. Okay. We cannot use these 2 locations to allocate anything into them. They are the only way that we can actually do any computation on this machine. And you know that there are only 2 things we can do. We can either add or we can complement. All the other instructions we have are either moving things around or jumping, to different parts of a program. So now the next place is what I'm going to use. I'm going to call this location 0x002 my I. Remember, this I is here. Okay. I'm going to put that I in there. Okay. So this is a location I can actually use because it's like free. There's nothing wrong with this location. Okay. Can't use these. Assign these to variables, but we can assign all the rest of the locations to anything we want. All other locations are fair game. These can be assigned to any place. These locations can be assigned to any variables.
So only the first one and the second one, which are for A and B, we cannot use.
We cannot use those. We cannot give them any variable no variable can be assigned to them.
Quick question.
Yeah.
Was there any reason why you set a specific memory address for I, but not like the sum variable?
I could put the sum there first and then put the I after, but there's good reason for it because in the 16-bit edition of this machine, we're going to take that location 2 out of the way also and make it a reserve location that nobody can write nothing into it. And we call it what we call an IX register, index register. We're going to make it more special in the 16-bit edition because we will have 2 instructions that'll actually use that particular register to eliminate the need or the sort of like solution that I'm going to present to you by way of a sophisticated sort of like copying process, which we call self-modifying code. We'll get to that in just a second. So there is a good reason why I call that I as opposed to sum.
Great, thank you.
All right. And now that you brought the sum, I'm going to use the next location for my sum. By the way, the remaining space will also be used for our programs. Remember, our programs also live in our memory, nowhere else. So all the variables in our own program, and there could be several programs, they will all live in this memory space. Okay, the same space, is also used to store programs. Okay, these are all there. Let me just move this up a little bit. So now we managed to put, I and sum into the memory of our system. The only thing that remains is so-called this array that we have to compute our program with, like that AI. Okay, so again, this could be mapped anywhere in the memory, but I'm going to put it into a specific location. I'm going to skip a bunch of these locations, okay, and I'm going to place it right here. Sorry about that. I'll just use this again. Okay, and this will be like A0, and this is 0x00A. Oh, interesting that this guy just doesn't write the right way when I have that vector mode. Okay, that is location A, that is hexadecimal. That means location 10, and into that location, I will place my A0. And into the next location, and I'll put a bunch of these, and the last one over here. So the next location after this would contain 0x, 0, 0b. Will have the second element of my array, which is A1. Okay, and then I continue like this until I get to this last location, which is 0x, 0, 1, 3. Now, if you compute that, you will find that to be 19. And that will contain my last, actually, I should call this 1. Let me just quickly fix it. And this will be my A10. Okay, now I've just mapped the array itself into my memory. Again, all of this is done by a compiler. We are not hand compiling this. That's all we're doing. We don't want to do this, of course. You know, if in fact we are at this age, that'll be almost like the Stone Age of computing. Like if I keep doing it this way, we would not have any of the things that we're using today, including this Zoom thing that we're using. All of this is done conveniently by compilers that generate these apps, and they're binarized, you know, whether it's through Java or some other C++, other technologies. And once the apps are created, they have all these, you know, bits and pieces. Now we're talking about several million lines of code that generate some of these humongous apps that we see here today. Okay, and they're all working harmoniously. They're just using some libraries that have been binarized already and made available to these app developers. You know, think about Eclipse, and we're using, for example, ourselves using Eclipse to develop this technology that I just showed you moments ago. Okay, and we probably exceeded, you know, a couple of 100,000 lines of code. And so this develops, you know, people just like do this sort of stuff all the time, but we never hand compile these things. The environments, the IDEs, integrated development environments, NetBeans, you know, Eclipse and Xcode and other things just provide us the capability. Anyway, let's get back to the work at hand, which was here. Now, the only thing that remained is, in fact, our program. We have to write a program to do this. So let me stretch this a little bit. I'll just add a little bit more piece to this. Well, yeah, I still have to learn this in a way that, first of all, I know how to draw these things, but then if I draw them wrong, I have the capability. All right, close enough. So let's leave some space here and put into here, right down here, maybe I just leave some space right after this, okay? I leave some space. And right here, this location, I want to start my program. So this is 0x, not too bad, 0, 2, 0. And this is where my program begins. And then it'll go to the next location until someplace. You know, I don't know the end of it yet because I haven't written the program. This would be, this is where this is where our program is loaded. we load our program to that place. So now you have a map of our, machine sort of code. We got this map, which gives us the ability to write the program now. We can actually start writing our machine program. Let's go ahead and start writing it. And then let's write the mega steps. This was our first step to lay it out. Now in the second step and the third steps, step and so on, let's just write the rest of it. So number 2 would be, clear sum. Number 3 will be initialize I. Number 4 will be initialize AI. That means, load it. Okay. And then number 5, compute the sum. As described in the code, in the C code. Okay, so let's get started and let's just do some of these steps quickly. Now I'm going to write the
Professor,
code. Yeah.
real quick question. What was the first step? I think I missed it.
Is that Gabe?
Yeah.
The first step was to lay it out here.
Oh, I understand now. Got it. Thank you.
You're welcome. We created the layout of our solution, and then now we're going to work. Okay, now let's just do some of these steps. What I'd like to do is to write all of the locations on the left, and right next to them, I would write the code that is needed to do all these steps. Okay, so I'm going to start writing now. First thing that we want to do is to clear the sum. So sum is in location number 3, and to clear it, we have to put 0 into it. And where my program begins is 0x020. Location, okay, so our program, here's our machine program. To do all these steps. Okay. I'm going to start at location 0x020. This is where my program's first instruction will ever appear. And the instruction that I want to use is a load instruction because I want to put a number into location 3. So here's what I say. Put into location 3 a number which is equal to 0.
I'm sorry, can we repeat this step before we move on? I think I confused it. I'm so sorry.
Okay, sure, I'll tell you. So I'm starting at location. This is the location, by the way. And this is the code. So I'm going to put into each and every location a code, a machine code. And the code will have to be one of our VESP instructions. So location 020 will contain the very first instruction. What am I supposed to do in that very first location? Well, I'm supposed to clear the sum. Now, where did I put the sum? Where did I say that the sum will go to?
0.3.
Yeah. And that's why you see there 2003. And now I want to put into it the number 0. That's how I do it. Okay. So what this does in English, explanation, comment, whatever, it says sum is equal to 0. That's what we did just now. the next thing that I want to do is to initialize the value of my so-called I. Okay, I'm going to say 0x022. Now I'm going to put a number into location, not 3, but location 2, because that's where I is. Note that the order of doing these things is just completely independent of each other. I could do that step that I just did after this step, which I will complete in just a second. Doesn't matter. Okay. Into this location, I have to put the very first location where my array is located. Now, where did I store my array? What was the first location? Location A. Now I'm going to direct my I to that very first location. That means I'm going to initialize it to that value. Here's what I do. 0, 0, 0, A. Because I want to start computing things out of that location. So that becomes 0x, 0, 2, 3. And this is just to say that I is equal to, I guess, the first location in let me just say it this way. This is clear. Okay. Maybe the location as opposed to the first location. You know, it's the same thing. It's just like maybe between quotation marks there. Okay, so you can see that here. If you look at it here, you can see that A1 is actually right there. And I just initialize it to that. That's all I did. So my I is, you know, as you can see, it's actually equal to 1 here, right? It's equal to 1, but all of a sudden in the translation, I has become 10. I translated. This is a translation. We're translating. We're not keeping things the same. Okay?
Professor,
Uh-huh.
on the location side, you're just going through all the like locations of where the program is, right? It's not really connected to the code side.
Well, these are the locations into which I'm going to now dump this code. I mean, these locations are holding my program starting at 020 hexadecimal.
Okay.
These
Okay.
are going to be in memory, just like, you know, my memory map showed. What did I say? This is where our program, if you just read that, right? I'm
Mhm.
actually now storing my actual program. I'm going to run this program.
Oh, okay.
In the
I
end.
see what you're saying. I see what you're saying. Yeah.
Yeah, we have to run this program to do the computation we need to do.
Gotcha.
Yeah, this is all hands-on thing. I mean, like this, there's nothing theoretical here. It's everything hands-on. What I'm writing here has to work because we have the C compiler, as I showed you last time, right? We have to be able to use this program. The program I'm writing is not something that exists in vacuum. It's going to run, and it's going to give us what we want it to give us. Okay.
I
So
have
now
a
that,
question also.
yeah, yeah.
Is there a reason why when you're accessing the location, so 003 and 002, you start the code with the number 2?
Number 2 meaning like 2 meaning this 2 here. I think you're referring to this 2 right there.
Yeah.
That's the opcode for load.
Oh, okay.
If it were to be moved, that would be 3. If it were to be added, it'll be 0. If it were to be complement, it'll be 1. If it were to be jump, it'll be 4. If you go back to, like all of our representations earlier on, and we put a lot of stuff in here already, what happened? I mean, somewhere in there, I must have defined these instructions, I guess.
Yep, I got it. Thank you.
Okay, you know what that is, right? I mean, we define them. And decoders, in fact, show you that the decoder shows you that already. Okay. There's a quicker way of getting this there. Okay. So now we're going to have to put the actual values of the array. And I didn't tell you exactly what I'm going to put in there. In other words, this is some array I have to initialize. Right? I'm going to add some values from an array of 10 elements. I didn't tell you what those elements will be. Now, I normally put into those locations something that is predictable so that when I sum them, I would know, very quickly what sum I should get. So typically I put into these locations 1 through 10. And, if you add 1 through 10, you should get 55 because it's like 10 times 11 divided by 2. That's called the Gauss sum. So I'll just keep the tradition. I've been doing this, for many years. I'm going to use that same example where my array will be initialized so that A10 holds, which is effectively A1, holds 1, A2 holds, or A11 in this sort of like memory scheme, holds 2, etc. So let me just do this. Okay, so let me just quickly do this. 0, x, 0, 2, 4. I'm going to write a bunch of load commands now. 2, 0, 0A, and I'll put the number 0, 0, 0, 1 in there. 0x, 0, 2, 5. Into the next location, I'm going to put in, next location meaning B, I'm going to put in number 2. Into the next location, 2, 8, I'm going to put in number 3. Okay, let's just continue a little bit. Into the next location, I'm going to put in 0, 2A, 0, sorry, not 0. 2, 0, 0, D, 0, 0, 0, 4. I can probably put one more. Maybe I'll just skip to the next place. So what you see that I'm doing here is simply putting my array, defining my array. And so let me just say this from this point, this was basically the initialization. And these right here, and I'll continue. Okay, initialize A, array that is, array A, 2, 1, 2, 10. Okay. I will continue to do this now. I just stopped at 4. Next place will be 0, x, 0, 2c, 2, 0, 0, e, 0, 0, 0, 5, 0x, 0, 2d, that is, 0x, 0, 2e, 0x, 0, 2f, 2, 0, 0, f, 0, 0, 0, 6, 0x, 0, 3, 0, 0x, 0, 3, 1, 0, 2, 0, 1, 0, 0, 0, 0, 7, 0x, 0, 3, 2, 0x, 0, 3, 3, and I'll put in 2, 0, 1, 1, 0, 0, 0, 8, 0x, 0, 3, 4, 0x035 2012 0009, and then there's one more place where I have to write 10 0x036 2013 0x037, then it's going to be 0008. So this completes let me just do it this way. Okay. Now all the values of array A have been initialized. So now we really have done what we're supposed to do. Okay. And now we have to write the rest of the code. Okay, so let's think about it for a second. What I'd like to do at this point in time is to start thinking about setting up a loop, because as you can see, there's a loop here. Everything that we've done up until now was all about initialization of these things. I guess this was, sorry, up here. Where was it right after this? Initialize. So we've done these things basically. Now we have to do step 5, which is to loop. And because the thing is, it's looping, right? If you look here, there's a loop. There's a for loop. So we're up to step 5 and we have to do the for loop now. So, you know, loops can be written in many ways. But we have something critical here, and that has to do with the with our limited capability to access numbers out of our memory. We got 2 instructions to do this with. One is called load, the other one is move. We've used load instruction to initialize our critical variables, I, sum, and our array, right? So if you just look at what we did here, you know, we started at 20 hexadecimal, we went all the way up to location 38, I think is where we are now, okay? And here must start our loop, okay? This is where our loop must be stored. So now let's think about doing the loop. As you notice that the last location that I have something that, you know, part of our array, the last element, which is 10, A10 that is, this is where a, you know, bracket 10 is supposed to be. This simply stores into location 13, our array A bracket 10. The next location, which is 2014 in the array up here, the next location, right there at the end of this, where I put some dots, that's not a good location for us. If in fact our I, the index pointer, reached that place, that means we've actually gone past our array. So I have to check now if my I has reached the so-called place 14. I'm going to keep incrementing this I, but before I go out and do any computation in my loop, I want to check to see if I reached location 14. because location 14 doesn't have anything of value for me. My array stops at location 13. So before I go and do anything inside this loop, like to copy something and then add it to something, right? I have to add an element of the array to the sum, running sum, if you like. In order for me to do that summation, I have to make sure that I am within my bounds of my array, which ends at location 13. So therefore, I have to check to see if I has exceeded or has become 14. And how do I do that? Well, I have a nice instruction, and since I will be incrementing this I from the first location to the last location, that is location A, where my first element is stored, to all the way to location 13, I have to check to see if, that place where my last element has stored, that place has been reached. Okay, so the first thing that I do in this loop, let me just say that, okay? And I'll basically write this here, okay? The first thing that we must do in the loop is to check if we have reached not reached, but yeah, we have passed we have gone too far. To get past the last element of our array. That is location 14. Okay, so now we have to do this test. I want to bring I into my A, and then B into my, maybe 14 into my B, or the other way around, and simply do a subtraction. Okay. So I'm just going to, I guess, put I into A and 14 into B, and then complement A and add it to B, and then add 1 to it to see if the difference has become 0. Okay, so in our program steps, and don't forget that I'm going to be, next location is 0x038. So here's what we want to do. Okay, so we need to test if I, okay, has become 14. And so for this, we will just do the following. Okay, now I'm just going to go to location. Here's how we do it. Invest 1.0. I am in location 0x038. That's my next location. 0x038. Okay, I'm going to load I into A. And how do I do that? When I say actual load, I should say move. So I'm going to say 3, 0, 0, 0. That means move something from a location into so-called the accumulator. This is the address of A, location 0. And I want to bring into this place the thing that sits in my I.
So does that mean you're moving from location 000 to 002?
I'm moving something from location 2 to location 0.
Okay.
Okay. And then next thing I want to do is to move 14 but not move, but load into B, this number 14. Okay. And that's actually hexadecimal 14 if you think about it. Which is location 20, by the way. But not in hexadecimal, but in decimal. Our program has been loaded into location 20 in hexadecimal, which happens to be location 32 in decimal. This number, this location 14 is 20 in decimal, which is still, away from some 12 locations away from our program would be located. So we're not really penetrating into the program space when we load that array into locations, I guess, 8 through 13 hexadecimal. So now we got, so here's what I want to write these things because I think comment should apply. Okay. Copy I into accumulator. That is, let's just call it accumulator so that you understand that it's not like some A that we'd be using. Okay. Load 14 into co-accumulator. God, it's 147. I didn't realize. You see that the time we wasted on at the beginning on that stuff, which is like, this is what I'm saying. Well, so I have to stop, obviously. It's 147. I cannot go forever. I know that you got, your schedule. All right, so let's say that this to be completed. Okay. Unfortunately, I think I would have been able to fit everything if we didn't, spend that time at the beginning. And for that, I again hold the IT people accountable. I'm going to send them a stern email, a very rough language. Okay. I'll try to hold myself back, but I'm just fed up with them. I mean, like 3 weeks into the semester, they still haven't been able to fix this. Anyway, I don't want to vent about it any more than I have. I'm going to rest my Apple Pen right next to its iPad sibling. Okay. And I'm just going to get ready for a faculty meeting, group meeting, and then I'll just have another class. Have a great evening, by the way, an afternoon, rest of the afternoon, and enjoy your whatever you cook or you order to eat.
Thank
Have a
you as well.
really
Thank you,
serious-
Professor.
Thanks,
I have a question, Professor.
Anytime.
Is it okay?
Yeah.
Yeah. Is it okay for the homework? Is it okay if you use circuit labs rather than draw them by hand?
You can draw them by hand. If you want to be neat about it, just balance your, budget wise time and, I mean, like I spend a lot of time. If I show you the things that I draw on my computer, you'll be amazed.
Oh, I bet.
I mean, I can share them. I just drew a very complex diagram yesterday because I'm teaching this other class. I want to explain things to my other students.
I have no doubt.
I do this, but I mean, I don't recommend it to everybody because it takes so much time. I could have watched a bunch of TV programs with my wife, or, I could go and see my grandson, all those things I could have done. I don't get to do because of those things. So like same way, I mean, to make the long answer short. I mean, if your time permits, yeah, it'd be great.
The only reason I asked is because if I end up making a mistake in the middle, sort of, it's easier to fix it if it's on circuit lab rather than if I draw it out.
You're right.
Then I would have to end up erasing everything.
Right. For example, this gadget that I've been using here, with all the eraser capabilities, any mistake I make or any misprint, whatever, I just quickly fix it.
Right.
It's a great- yeah.
Thank you.
For your office
You're
hours,
welcome. Yeah.
Do we have to set a time with you if we want to like meet with you and
If
ask?
you know, I prefer email correspondence, Yekta, but if you really want to have an office hour, you know, you just think that it'd be very useful to you, you know, I'll be happy to set up time.
Okay, should I email you about that or should we just set a time right now?
No, not publicly. You can send me an email, and you know, I'll be happy to. And also, as I think said this to other students, you know, Sean Ming is a very capable TA, extremely capable TA, and don't underestimate his you know, level of knowledge for this class. He knows a lot, and he can really help you when you go to his discussions. You know, so the course is kind of created. That's why we have these discussion sections where, you know, I'm sure that, I mean, I know that when we used to be on campus, you know, TAs would tell me that, you know, only a few people showed up and show up, and, you know, and that, you know, they're not really interested in asking questions, and that's, so you just use that time. And, you know, because I think he's there on Fridays, I believe. Is that right, Xiaoming?
Yeah. I'm there Friday.
Yeah, so he's there on Fridays, you know, get onto his class just as aggressively as you get into my class. And, you know, he's going to go in slow motion. He's going to explain all these things that we're doing in slow motion. And he will work it out. Now, if you have, you know, a personal issue that you're finding it difficult to understand this, there are some technical things that you have to overcome, you know, I'd be happy to meet with you. But the technical content of the class should be deliverable. If we don't do that, that means we're making a mistake somewhere. Between my lectures and Xiaomin's discussion sections, we should be able to give, and you know that you can ask questions, right? I mean, like even now, right? I mean, you asked a couple of questions. You always can ask questions. I also understand that somebody actually wrote to me. That's you know, nice to know. Our department is facilitating a tutor for this class. So he asked me if in fact he should do it, and I will encourage him to do it. And I think he will announce it to the class, then, you know, he's going to tutor this. So if you need, I think it's basically free tutorship from the department. If you need his assistance, then I think he'll be available to you too. So all those things are at your disposal. And, you know, I will be there as a last resort if something doesn't click. And if you really have to, you know, sometimes you have this, you know, this idea that professor knows everything. The TAs maybe are not as capable, you know, tutors probably. That's not true in this case. I mean, because you are a young generation, you know, I'm getting pretty close to 70 years of age. And what that means is, you know, like you guys have much fresher brain cells, neurons firing up in your brains. You're much more intelligent and sharper than me. And I'm sure that, you know, you guys will conquer this subject very easily. And my role is a catalyst. I just want to, you know, impart my years of experience in this field. That's all I'm doing.
Professor.
Yes, Yekta, does that make sense to you?
Yes, sir.
So send me an email if you really think that you have to ask me questions. Okay.
Okay.
You're welcome anytime. Yes. What was the question? Next one.
This is Joseph. I'm
Joseph.
actually the tutoring person.
Oh, you're the okay. There, yeah. Here's the tutor who's actually in class already.
Possibly. I haven't decided yet.
All right, decide it
gonna
now. Decide it now and become a tutor because you asked that question to me.
Well, I was gonna talk to you about it if you have like a couple minutes.
All right. Well, I mean, you don't want to do it publicly, you know, at the end of the class. Yes, let's do it.
Right now? Okay. I just wanted to know, is the class gonna be structured very similar to how it was?
Identical.
Okay. And I know there are some things in the class where I'm less sure about, like near the end, it got a little complex. You think that'd be fine for being a tutor if I'm still?
I think so. Towards the end, you can stop tutoring.
Okay. Guess that makes sense.
If you are not capable of tutoring, you can say, I can't tutor you anymore because I don't know this stuff myself. That's fine.
Yeah,
I don't think that's a
I'll also have to look at my schedule because like I might have too many classes, but If I do, then I will let
Joseph,
you know.
commit
And
to it, you will feel very good at the end of this. You say you will have helped some, younger generation of 350 students. Now that you've gone through this and you understood most everything. I respect your time, your schedule, but if you decide to do it, I think it'll be very helpful. And then you probably, will set up some time, and they probably give you some, time sheet to fill out. Correct?
I believe so.
Yeah. So you can limit that time. You can say, I can only do this, for 2 hours a week, 3 hours a week, maybe half an
Yeah, I
hour.
think
It's
they
up
say
to
it's for 2 hours a week.
how many hours?
2 hours a week.
Yeah, look at that. I mean, just like assume that just like I couldn't do it, like not able to watch a movie that you wanted to watch, just like I can't do those things anymore.
Yeah.
Sacrifice, say, hey, I will just let go this movie of John Wayne or this and that, whatever, right? Whatever movies that you want to watch or whatever programs, just say, I'm going to cut down on that one for 2 hours a week, and I'll have my fellow, I guess college mates or department mates, whatever you want to call them, but people who are coming right after you. And, it'd be helpful if you actually did, but I respect whatever decision you make, Joseph.
All right, great. Thank you for talking to me. I'll let you know what.
You let us know, and then I'll just let the students know that you're actually available or not. Okay?
All right, great. Thank you.
Yeah, you're welcome. Good to talk to you again.
And I have a question for Xiao. I'm sorry if I pronounced it wrong. Xiaomin.
Yeah, go ahead.
Yeah. So you mentioned last Friday you were going to send out a poll. Am I missing something, or did you not do that yet?
I think I put it in Piazza if you want to check it out.
Yeah, I was looking. I wasn't able to find it. Are you able to pin the post or tell me what number it was?
Office hour votes.
Oh, it's
You
on
can-
their office hours. Okay.
Office hour votes.
Okay. Yep. Thank you.
All right. I think
All
we're
right.
down to, yep, we're all set.
Yeah,
Okay,
thank you,
everybody.
Professor.
And I'll
Thank
see
you.
you. Yeah, anytime. Anytime I'm here. I'll see you guys on a Tuesday next week.
All right. See you,
See
Professor.
you, Professor. Thank you.
Thank you. Thanks, Xiaoming. Take care.
All right.
See you. Bye-bye.
All right. Bye bye.